It's said in space that nobody could hear you scream, and that's true. But here's the part that most people don't realize, that the universe does produce waves, and if we could hear them the way they actually exist, things would be a lot different for us, to say the least. In this video, I'm going to be breaking down the real sounds of space, aka the universe. We'll cover what scientists have actually detected. We'll talk about what NASA is releasing when you hear those viral clips like black holes vibrating galaxy clusters and space-time ringing after massive collisions. And we'll finish with a time in our history when the entire universe could carry sound. I go by Space with Spo. I'm reporting for Science Alert. Just a quick reminder to subscribe to this channel. By the end of this short video, space won't feel so empty anymore. Okay, so if you didn't know, sound needs something to travel through. On our beautiful blue dot called Earth, air carries vibrations easily. At sea level, trillions upon trillions of molecules are packed into every cubic meter. So when something moves, those molecules compress and pass the vibration along. Now, space, on the other hand, is a little different. Between planets, there's only a few scattered particles per cubic meter, and between stars, even fewer. So if you screamed in interplanetary space, there's nothing dense enough to carry that vibration to anyone else. Now, having said that, space is not perfectly empty, and where matter gathers, things get extreme. In 2022, NASA released audio-based observations of the Perseus galaxy cluster around 250 million light years away, and at its center sits a supermassive black hole. Now, surrounding all this is hot gas filling the cluster, but moving through that gas are pressure waves caused by the black hole's activity. And here's what it sounds like. Turn the speakers up. I'm not even trying to be funny. Why do I feel like this thing's talking to me? Okay, so those waves were detected in X-ray data from NASA's Chandra X-ray Observatory. Now, the original frequency is way too low for human ears. One full wave would take like millions of years to pass, so scientists shifted the pitch upward about 57 to 58 octaves to make it audible. So what you're hearing is pressure ripping through hot galaxy cluster gas. So it's not sound traveling through empty space. It's gas responding to the insane energy of a black hole. So that's matter vibrating, but now let's talk about space-time itself. In 2015, scientists at the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected something that still keeps me up at night to this day. Now, I stay up for a few reasons, one of them being that we are a species on a floating rock in an expanding universe. But we can talk about my sleep schedule another time. Right now, let's focus on the two black holes that merged more than 1 billion light years away. This specific event was named GW150914, and these two black holes that spiraled together didn't just disturb nearby matter. They warped space-time. Ripples then moved out across the universe. And by the time those ripples reached Earth, they were unbelievably small, changing distances by less than the width of a proton. But LIGO, because obviously it's LIGO, detected them, and scientists converted that signal into sound. Take a listen. Now, that little chirp lasted about 0.2 of a second. The frequency climbed to roughly 35 to 250 hertz as the black holes spiraled faster before merging. So right now you could hear a little piece of space-time ring. I mean, that could be some type of text message alert. The universe saying somebody's trying to contact you. Matter of fact, I just set that to mine now. All jokes aside, there was a time when the entire universe could carry sound. About 380,000 years after the Big Bang, the universe was dense, hot, and filled with plasma of charged particles and light. It kind of behaved more like a fluid than empty space. Pressure waves moved through that plasma. We're talking real sound waves. The entire cosmos was essentially ringing. And as the universe expanded and cooled, those waves stopped traveling. Matter condensed into stars and galaxies, but the waves left a pattern behind. Today, astronomers can still detect that imprint and how galaxies are spread out across distances. These are called baryon acoustic oscillations. They are the fossil imprint of ancient cosmic sound. We can actually use them to discover the rate of dark energy in the universe, but again, that's another video for another day. So we'll talk about my sleep schedule, then we'll talk about dark energy. So to wrap this all up, yes, space is silent. You can't just shout across it. But do me a favor and remember these three things. Black holes can drive pressure waves through galaxy clusters. Colliding black holes can ripple space-time itself. And the early universe once carried sound across everything. And you know what? We live in the quiet aftermath, and maybe that's a good thing. If you like this video, make sure to subscribe to the Science Alert channel. Hope you have a great night, and we'll see you next time.